In this video, we're going to talk about how to calculate the derivative of a general logarithmic function. So, the derivative of a general logarithmic function, so you'll get a function, for instance, that takes this form, log base a of x. The derivative of that is equal to 1 over ln a times 1 over x. Or, a better way of looking at it is the derivative of log base a of the absolute value of x, I should say, is equal to 1 over ln a times 1 over x times the derivative of x. You can even look at it this way. The derivative of log base a, there should be an a here, okay, log base a of some thing, okay, whatever is in this box here, okay, whatever is in the argument, is equal to 1 over a times 1 over the whatever's in that argument here times the derivative of whatever's in this box here. So we'll do an example, but before we do that, just one thing to keep in mind is that a has to be greater than 0, and box, okay, this argument here, or x, whatever you want to call it, cannot equal 0. So let's do an example. So let's say we're given the function f at x. Okay, f at x is equal to log base 3 of x squared. Okay, so what is our derivative going to be? So f prime at x. So keep in mind here that a, okay, the base is 3, and then x, or I should say this box here, okay, is x squared. So to evaluate that derivative, we just follow this format here. So 1 over ln a times 1 over box times d box. So 1 over ln 3 times 1 over x squared times the derivative of x squared. So we know that the derivative of x squared from our power rule is 2 to the power, or sorry, 2x, or 2x, let me write this a little bit better here, 2x to the power of 1. And so we can further simplify that by writing 2 to the power of x, okay, because we don't necessarily have to put that 1, over x squared ln 3. And we can simplify this even further too, because the x's cancel out. Okay, so this x cancels out, so we can cancel this x here with that. And so we can further simplify this to 2 over x ln 3. And that would be the answer for this derivative here. So let's say we were to do another example. So let's say we're given a function g at x, we'll call it. Okay, g at x. So I'm going to come down a little bit, create some more space. Okay, so g at x is equal to log base a of sine 3x. Now keep in mind I haven't really given you an explicit number. A is just some random constant. Okay, so what would be our derivative g prime at x? Well, it'll be the exact same steps. So g prime at x is equal to, okay, 1 over ln a, Okay, 1 over ln whatever the base is here. So 1 over ln a, the natural logarithm, or the natural log of a, times 1 over this entire term here, okay, which is, in this case, sine 3x, so times 1 over sine 3x, sine 3x, times the derivative of sine 3x. So the derivative of sine 3x, okay, the derivative of a sine function is a cos of that function. So cos 3x times the derivative of whatever's in this term from our chain rule here. So times 3. Now, of course, we can go ahead and simplify that. Okay, to the way I'll write it for this particular case here is I'll write 3 over ln a over ln a times cos 3x over sine 3x. Now, why am I writing it this way? Well, remember that a sine over a cos is a tan function, and a cos over a sine is a cotangent function. So this entire term here can be rewritten as the cotangent of 3x, okay, or 1 over tan 3x. So what I can do is I can write it like this. I can either simplify it this way, which is 3 times the cotangent of 3x over ln a. Okay, that works. Or I can write it this way. I can write it 3 over, okay, or sorry, ln a. Let's write that there. I can write this 3 over tan 3x ln a. Okay, so both those answers would be correct. So there you have it. That's how you evaluate the derivative of a general logarithmic function.